Hello everyone, in this lecture we are going to learn about line integral, surface integral and Green's theorem in a plane. So now first let us start with the definition of line integral. The line integral is defined by integral over C f vector dot dr vector or integral over C f vector dot dr vector by dt into dt, where f is a continuous vector function. And circulation is nothing but if f vector represents the velocity of a fluid particle, then the line integral is called the circulation of f vector around the curve. When the circulation of f vector around every closed curve in a region E vanishes, f vector is said to be irrotational in the region E. So now let us start with the problem here. If f vector is given by this vector and we are supposed to evaluate f vector dot dr vector, and C is nothing but the curve in the xy plane y is equal to 2x square from 0, 0 to 1, 2. Since we are speaking about the xy plane, r vector will be defined as xi vector plus yj vector, and there is no z at all, therefore z will be 0 since because of xy plane. So r vector is simply this. So dr vector will be equivalent to dxi vector plus dyj vector. So integral f vector dot dr vector will be equivalent to integral. When you take the dot product between this f vector and this, you will get 3xy into dx minus y square into dy. So now here we are going to integrate this either with respect to x or with respect to y. So accordingly we are going to do some changes in this integral. Given the curve y is equal to 2x square, when you differentiate this you will get 2y is equal to 4x dx. So wherever you have y, that can be replaced by 2x square and dy can be replaced by 4x dx, so that the full and full the integral will be written in terms of x. And you can observe that the limit for x, the points are from 0, 0 to 1, 2. We can observe that x varies from 0 to 1. Therefore, you can write this as integral 0 to 1. This is 3x into 2x square dx minus this will be 4x to the power 4. In the place of dx it is 4x dx. So this is equivalent to, in the place of dy it is 4x dx. So this is equivalent to integral 0 to 1 6x cube minus 16x to the power 5 dx. So this will be equivalent to, when you integrate this, integral x power 3 will be x power 4 by 4 minus 16 times x to the power 6 divided by 6 over the limit 0 to 1. So this is 6 by 4 minus 16 divided by 6. So you can write this as 3 times, this is 8 times over here, and here it is 2 times, and this is 3 times. So here it is 3 by 2 minus 8 by 3. When you take the LCM, this is 9 minus 16 divided by 6. So this will give you minus 7 divided by 6. Therefore, integral over C f vector dot dr vector is nothing but minus 7 divided by 6. Now we will move on to the next problem. Find the work done in moving a particle in the force field f vector equal to 3x square I vector plus 2xz minus yj vector plus zk vector along the straight line from 0, 0, 0 to 2, 1, 3. So, and an important note is here that the work done of f vector during the displacement from A to B is given by the line integral A to B f vector dot dr vector. So, f vector is already defined, and here we are supposed to write what is r vector. So, r vector is nothing but xi vector plus yj vector plus zk vector. Therefore, dr vector will be equivalent to dxi vector plus dyj vector plus dzk vector. Therefore, f vector dot dr vector will be equivalent to 3x square dx plus 2xz minus y into dy plus dz, that is z into dz. I am just taking the dot product directly with these two, that is f vector dot dr vector is given by this, and we need to convert everything in terms of t by using the straight line form. We are going to get a straight line from the point 0, 0 to 2, 1, 3. So let us consider this as x1, y1, z1, and this is x2, y2 and z2. The straight line equation will be given by x minus x1 by x2 minus x1, which is equivalent to y minus y1 by y2 minus y1, which is equivalent to z minus z1 by z minus z1. So this is nothing but x minus 0 by x2 is 2 minus 0, which is equivalent to y minus y1, that is y minus 0 by y2 is nothing but 1 minus 0, which is equivalent to z minus 0 by z minus 0 by z2 minus z1. z2 is nothing but 3. So this is 3 minus 0. So this is equivalent to x by 2 is equal to y by 1 is equal to z by 3, which is nothing but equivalent to psi sum t. So x will be equivalent to 2t and y will be equivalent to t and z will be equivalent to 3t. So by doing this way, all the variables will be written in terms of t and you can easily find the limit for t also. So the points are nothing but 0, 0, 0 to 2, 1, 3. So we could observe that t varies from when x is equal to 0, t is going to be 0. And when t and y is equal to 0, t is 0, and when z is equal to 0, t is 0. And same way, when x is equal to 2, t is going to be 1. And y is equal to 1, t is going to be 1. And when x is equal to z is equal to 3, t is going to be 1. Therefore, t is going to vary from 0 to 1. So, integral f vector dot dr vector will be written as integral 0 to 1, everything we are going to convert in terms of t. So, this is equivalent to 3x square, that is 3 times x is nothing but 2t the whole square and dx means you are going to differentiate this term. When you differentiate, dx will be equivalent to 2 dt. So, this will be 2 times dt, then plus 2 times of x into z, x is nothing but 2t and this is 3t, 2xz minus y, that is minus t into dy. dy is nothing but when you differentiate this y, dy will be dt. So, in the place of dy it is dt, then plus z times, z is nothing but 3t into dz. So, differentiation of 3t is nothing but 3 into dt. So, now we can simplify this. So, this will be integral 0 to 1. So, 2 square will be 4, 4 times 3 will be 12, 12 times 2 will be 24. So, this is 24 dt and here 3 times 2 is 6, 6 times 2 is 12 t square. So, this is plus 12 t square minus t into dt, then plus 3 times 3 is 9 t dt. So, this is nothing but integral 0 to 1, 24, here we have t square term. So, 24 t square. So, this is 24 t square and here it is plus 12 t square minus t plus 9t into dt. So, when you simplify this, 24 plus 12 will give you 36 t square and from these two terms it is plus 8t. Therefore, so let me write it here in this place. So, this is integral 0 to 1, it is 36 t square plus 8t into dt. When you integrate this term, this is 36 t power 3 divided by 3 plus 8 into t square divided by 2 over the limit 0 to 1. So, this is going to give you 36 by 3 plus 8 by 2, that is after applying the upper limit and lower limit. So, when you cancel out, so this is going to give you 2 times 4 and this will be 3 times 12. So, this is 12 plus 4 will give you the answer as 16. Therefore, the work done is nothing but 16. So, now we will move on to the next definition, surface integral. The surface integral is given by integral over s f vector dot ds vector or integral over s f vector dot n vector into ds. This n vector is nothing but the unit outward drawn normal vector. So, now let us learn about the Green's theorem in the plane. So, if you have two functions phi of x comma y and xi of x comma y and the derivative is phi with respect to y and xi with respect to x be continuous in a region E of the xy plane bounded by the closed curve C, then integral over C phi dx plus xi dy is equivalent to double integral over E dou xi by dou x minus dou phi by dou y dx dy. So, now let us start with the problem. Verify Green's theorem for integral over C xy plus y square into dx plus x square dy where C is bounded by y is equal to x and y is equal to x square. So, by the statement of the Green's theorem you can understand that it is a relationship between the line integral and the double integral. So, now let us sketch the region and C is the region bounded by y is equal to x and y is equal to x square. So, let us draw this is x axis and here this y axis. Y is equal to x is a straight line passing through the origin and y is equal to x square is the parabola which is open upward. So, this is y is equal to x square and the point of intersection of these two is nothing but y is equal to x square, just substituting in the place of y y in the place of y we are replacing it by x. So this x is equal to x square, or simply x square minus x equal to 0. So when you take x common, it is x minus 1 equal to 0, which implies x is equal to 0 and x is equal to 1. So the coordinates are nothing but 0, 0 and this coordinate is nothing but 1, 1. Okay. So always we are supposed to travel in the anti-clockwise direction. So let me move along this way and come back to the same position along this way. So let us call this as C1 and let this one be C2. So according to this Green's theorem, it is integral over C phi dx plus xi dy is equivalent to double integral over E dou xi by dou x minus dou phi by dou y into dx dy. So now let us consider the left hand side, that is integral over C. Phi is nothing but xy plus y square into dx plus x square into dy. So this is equivalent to integral. This curve is being written as C1 plus C2. So we are supposed to discuss along C1 and along C2. So first let us consider along C1. So along C1 what is happening? Along C1 y is equal to x square. Y is equal to x square. So dy will be equivalent to 2x into dx. Okay. So wherever you have y, that can be replaced in terms of x with the help of y is equal to x square. So this will become integral over C1 is equivalent to integral x into x square. In the place of y we are replacing it by x square plus x square the whole square into dx. Then plus x square into, in the place of dy it is 2x dx. So this is equivalent to integral, and what is the variation for x? So x varies from 0 to 1. Okay. So the limit for x is from 0 to 1. So this is integral 0 to 1, and here it is x cube, this is plus x power 4 and here plus 2x cube into dx. So this is integral 0 to 1, 3x cube plus x power 4 into dx. When you integrate this term, this will be 3x power 4 divided by 4 plus x power 5 divided by 5 over the limit 0 to 1. When you apply the limit, you will get 3 by 4, already this x cube, okay. So this is 3 by 4 plus 1 divided by 5. So this is going to give you 15 plus 9 divided by 20, so 5 3s are 15, 4 1s are 4, okay. So this is going to be 4 divided by 20, which will give you the answer as 19 by 20. Therefore, the value of integral over C1 is nothing but 19 by 20. In a similar way, we are going to find along C2. So along C2, you can observe that we are travelling in the anti-clockwise direction. So x varies from 1 to 0. So here x varies from 1 to 0. And the curve is nothing but y is equal to x, therefore dy is nothing but dx. So this is integral 0 to 1, in the place of y it should be x. So x into x will be x square plus x square into dx and plus x square, instead of dy it is dx. So this is nothing but integral, it is 1 to 0, once again. So this is 1 to 0, the limit is from 1 to 0, okay. So here also it is 1 to 0, 3x square dx. So this will be equivalent to 3 times x cube divided by 3 over the limit 0 to 1. So this will 1 to 0. So here it is 1 to 0, 3 will get cancelled, and when you apply the limit, the x cube over the limit 1 to 0, this will give you the answer as 0 minus 1. So this is minus 1. Therefore, integral over C is nothing but integral over C1 plus C2. Along C1 we got the answer as 19 by 20, and for this part it is minus 1. So this is equivalent to 19 minus 20 divided by 20, which will give you the answer as minus 1 by 20. Let us mark this as equation number 1. Now let us consider the right hand side. So in the right hand side we have double integral over E dou xi by dou x minus dou phi by dou y into dx dy. So we have got the function xi is equal to x square and phi is equal to xy plus y square. So now let us differentiate this term. Dou xi by dou x will be 2x and dou phi by dou y will be equivalent to x plus 2y, right. So now this is equivalent to, let me write it here itself. So now here this is double integral. In the place of dou xi by dou x, it is 2x minus dou phi by dou y, that is x plus into minus is minus again. So x minus 2y. Here it is dy into dx. Now let us find the limit for these things. Let us draw a strip in the region. So if we take a vertical strip, then it is a limit form. Then the variable limit will be in terms of y. So in the bottom it touches at y is equal to x square, in the top it touches at x. So the limit for y will be from x square to x. Limit for y will be from x square to x. When you swipe the region from bottom to top, x varies from 0 to 1. Therefore, the limit for x will be from 0 to 1. Therefore, this is double integral 2x minus x is plus x minus 2y, and here it is dy into dx. Limit for x is from 0 to 1, y is from x square to x. So, this is equivalent to integral 0 to 1. When you integrate this with respect to y, you will get xy minus 2y square by 2 into dx over the limit x square to x. So, 2 will get cancelled, and this is equivalent to integral 0 to 1. When you apply the upper limit, it will give you x square minus x square, then minus lower limit will give you x into x square will be x cube minus x square the whole square will be x to the power 4 into dx. So, these two will get cancelled, and this is minus integral 0 to 1 of x cube minus x to the power 4 dx. When you integrate this, this is minus of x power 4 divided by 4 minus x to the power 5 divided by 5 over the limit 0 to 1. So, this is minus of 1 by 4 minus 1 by 5, which is equivalent to 5 minus 4, that is minus of 5 minus 4 will be 1 divided by 20. So, this is nothing but minus 1 by 20. So, this is equation number 2. So, from equations 1 and 2, we could conclude that the Green's theorem is verified. Okay. So, we will stop this. Thank you.